change the default of it to 1, and now we have access to this. So if I then run this through another vector math node in between here, and I multiply the noise by this map, we will see that now the noise is only affecting the middle, and we can change the strength of it like this. Now another issue is that the noise is moving quite the same way, quite coherently. That is because each one of these curves is basically using the same spatial parameters for the noise, and what we want is to offshift them, offshift that, or just shift that a little bit using a certain number. So basically we want a unique number for each one of our curves, and that is what we're going to plug into this W parameter, which is like the shift forward. Let me just give this some noise so you can see what's happening. So as I'm changing the W, you can see the noise is shifting, and I want a unique number plugged in here that is associated with each spline. The easiest way to get that is to get an accumulate field node. So the accumulate field node, if I set it to integer and set this from point to spline, means that it will take the value of 1. Basically, how to explain this? If we have multiple splines, this will return a value of 0 for the first one, 1 for the second, and so on and so forth by accumulating whatever value is passed into this socket. So if I set this to 2, then the second value would be 2, and the third one would then be 4. And that's how I can set up a specific number for every point along my spline. So all of these would be 0, and so on and so forth. So that will allow me to get a unique number that I can then drive every spline's noise with. And what the difference is between leaning and trailing is basically if I use trailing, I will get this configuration, but if I use leaning, the first one would be this number, so it would be 2, 4, 6. In this case, I'll use trailing because that just makes more sense to me, but you can use whatever, and I'll set this to a high value so there's a bigger difference between each spline, something like 5 ought to do. And now if I just set another math node, I can still make use of my W parameter by shifting it like this, and now you can see that they're moving mostly randomly. So we have now offset that that equilateralness, or just equality that was before, and we can continue with, well, basically if our arcing is done, because now we can control the strength of the arcing and the noise, which I would honestly lower even more to something like 0.5. Now we can make our lightning arc quite a bit. And if you're further away, you might want to bump this value up so that it arcs more in random directions. But basically, we want to take all of this, including the set position node, and group it up, and we will call this arcing. And of course, we want to be able to control a couple of things. So I would take the arcing's group input, and I would just add to it like the scale here. And also, I guess I want to shift the W. So I'll add this thing, and I'll rename it the W, because this is now our control for the noises W. Another thing we want to control is the scale. I'll plug that in, and I guess now we have 2 scales, so I'll call the second one boost, because it is basically a boost to the arcing, and we're really done here. So this is going to be our arcing. We have full control over it, and basically in order to get noise, because that's what we want next, it's pretty much the same node, so I'm just going to duplicate this, but also press this number to make it a unique node. I'll plug this in the middle, and the noise we're going to be adding along this lightning, the only difference with the arcing is that it doesn't really need accumulate field, so you can trash that, and you can control the W directly. And in fact, the scale just needs to be much finer, something like 10, for example. Or no, I mean the scale. Actually, the scale here is very big, which means it's probably not connected to the right thing. Yes, indeed, the scale is not connected correctly here. Just give me a second to fix that. There we go. So now this scale is controlling, or is it? Scale to scale. Scale to scale, W to W, and boost to boost. Yeah. And the scale should be, except my boost is very low. That's probably, I'm going to just mute the second node for now, because I kind of messed up my connections here. Basically, we want this at 0 to 5, and we don't want the boost to be too high at this distance, and the W still works. Alright, so for the second node, I'll unmute it now, and I'll actually mute the arcing node. I will rename the second node to noise, because that's what it's going to be handling, noise along the actual lightning. And what we need to change on the second node is, again, the basic setup that's here. The difference is that the scale is much finer. So I'm going to reconnect the scale. This one is also inappropriately connected. I'm sorry, I messed these up a little bit. So just make sure the names are correct. Okay. Yeah, so a very fine scale here. You see that as you increase the scale, it gets more noisier with a little bit more boost. There we go. There we go. That's pretty much what we want. Sure, go ahead, play around with this. What you're gonna notice though is that after I enable the arcing, the lightning might behave a bit weird. Like it's a bit stretched. There's a lot of it here, but not so much over here. That is because the arcing, if I disable the noise, stretches out these splines quite a bit, and that means uneven points along the spline. So to fix that, I will simply plug in another resample curve with the same length as the first one. Okay, and yeah, now you can see we have more even distribution of lightning, but except not at the end and start, because that's what we want thanks to our UMAP. I guess you need to control this from the outside, the resample amount. So I'll plug that in, and now we're done with the arcing and the noise. If I then have a single value driving their W, we should get a fairly cool effect. Yep, there we go. We can see our lightning just sort of moving. And by the way, the whole thing should pretty much be working now. If I just, yeah, there we go. You can see we have our distance-based lightning. Now, lightning doesn't really just have these things going for it. It also has forking, like these electricities would like spike in different directions, and that's what we're gonna do next. I'm just gonna boost the lightning a little bit here. So the forking, to do the forking, first off we'll need a joint geometry node in the end, and the forks are basically gonna be copies of these splines. So I'll copy them using instance on points, and to have a specific number of copies, I'll just use the mesh line. If I set it to 2 and set everything else to 0, that will give me exactly 2 copies, because that's just the number of points I want. And what I want to be copying is of course this geometry, so that's my instance, and then I want to join these instances with the joint geometry node. Then I'll go ahead and group these things. I will call this forking, and basically this should be the setup at this point. And now in here we need to actually have some controls. The count, the number of forks, is just the count on the mesh line. Of course we need to realize these instances, set position, okay, and then we're going to push these splines, because they're currently overlapping with the original splines, along the normals. So we've done this before. Just take normal, vector rotate, plug that in, and we're going to just rotate the normal vector around the tangent. So tangent, vector, normal, and the value we're rotating with is going to be random. So we once again need a random value for each spline, so we know how we do that now. Accumulate field. It's probably fine to just leave this at 1. All I need to set this is to integer and then spline, and then I will use this random value, or rather this unique number, to drive a random value, and this random value will be between 0 and 2 pi, because that's a 360-degree rotation radians, and then I'll just take leading, or rather trailing, and plug that into the ID. So as soon as I connect this up to the end, I should see all my splines rotated around the original ones, but I want them to be rotating more as they get towards the end. So to do that, a vector mat node set to multiply. In between here I will plug in a or rather just the spline parameter, because the spline parameter goes from 0 to 1 towards the end, and we want this effect to be stronger at the end. Of course, some way to control this would be nice, because it's too strong right now. So a mat node right after the spline parameter, and now see, we can control that. However, I chose spline length. I need spline parameter. My bad. Spline parameters factor. Alright, there we go. So as we're getting towards the end, now we're pushing away in a random direction. However, this is very linear, so I would also pass this factor through another mat node that is set to power. And what that will do is it will take this linear transformation and just taper it off, because that makes more sense to me at least. So set that to 2, and now, in fact, maybe even 4. You see that we're really forking out as we get further towards the end. And another thing, is currently we are splitting at the start. We don't really want that. We want to split these forks at random locations along the original lightning. To do that, I will use a map range onto which I will pass. Yes, this map range has to be before the control for the scale. And what it needs to use is this minimum value. You see, as I change the minimum value, we're splitting higher and higher along the chain. And basically, I'm going to plug a random number into here. So I'm going to copy this random value. And if I set it to 0.1 and 0.9, then somewhere along this factor of the line, it will split up. And then again, I will load up the ID, and I will set a minimum value. So if I change the seed, now our lightning is splitting from the original at a random location. Alright, so then after that, the problem is that all this residual lightning is the same length as the original one. I guess you can you can't really see that. If I hop out here to reduce the number real quickly, because we have way too much lightning. 1. Perfect. That'll probably be fine. Hop back into the forking node. You will see that we do have 2 splines going out, and I can change it with the seed. But the issue is that, well, first of all, they're all rotated the same direction. And why is that? Because this needs to be a bit higher than 1, otherwise it doesn't count correctly. Yeah, so accumulate field has to have a slightly higher value, I think. Yeah, now they're random. Now they're essentially random. But they're all the same length. So to change the length, I will give it a delete geometry node. The delete geometry is going to work based off of selection on the spline parameter. So what I'm going to say is that if the factor is above a certain value, so greater than, and this is the factor, if the factor is greater than a certain value, which will be a random value, and the minimum for this random value will be the value we get from here, well, the maximum could be somewhere along towards the end. 0.9 is probably fine. And if I now plug this in here and this in here, you will see that it's now cutting them off at a random distance from the end, and I can change that distance. Yep. So exactly what did I actually do here? Let me explain it a little bit more. We have our original lightning. We spawned a bunch of lightning around it, and then we rotated that lightning randomly using the accumulate node set to a pretty high value here, and 0 to 1, this whole thing. And then I just chopped them off at a random location that is between this point and the end.